Hello everyone, my name is Ernie Romeo. I am with ABT TRAC and we manufacture stabilizers, thrusters, and integrated hydraulic systems. We have been supplying equipment on Nordhavens for over 20 years. Today, I've been asked to talk about our TRAC stabilizers and how they compare to gyro stabilization. But first, I'd like to touch on why stabilization is important. Stabilizers are generally considered equipment that allow you to have a more comfortable ride. Enjoy your time on board more. You can relate a more comfortable ride to less fatigue. Imagine not having stabilizers and being on a long run and constantly using your sea legs to maintain your balance. Stabilizers reduce that requirement, allow you to be more relaxed and arrive more rested, less likely to have fatigue-related mistakes. I think that is why having good, reliable stabilizers is so important to long-range cruisers. Gyro stabilizers have been getting a lot of attention lately due to intense marketing. Some people think gyro stabilization is new technology. In fact, it's been around since the early 1900s. The first gyro stabilizers were installed on the USS Henderson in 1917. So you can see gyros have been around for a while and they're not new technology. Fin stabilizers were introduced in the 1930s and overtook the gyro stabilizers for most of the 1900s because the gyro stabilizers were just too massive, too heavy. The gyros operate by spinning a flywheel at a high RPM. The combination of the mass of the flywheel and the speed equate to angular momentum. Angular momentum resists change to its rotational axis. This can be easily related to a child's toy, the spinning top. When the top isn't spinning, gravity takes over and it falls. When you spin the top, it has angular momentum and it resists gravity until eventually friction takes over and it eventually falls. The gyro stabilizers operate in much the same fashion. They spin a mass on a vertical axis, and it's going to want to resist any change to that axis. It's mounted to the hull, and it applies a torque to the hull to keep it upright as much as its capacity allows. This passive approach is the same for whether underway or at rest. Fin stabilizers use actuators to rotate fins external to the hull. When there's no change in heel angle, the fins are parallel to the water flow and there's no forces imported on the hull. When the system detects a change in heel angle, detects roll, the fins rotate, and they generate lift, very similar to an airplane wing. So the combination of two fins working on the hull, both imparting lift at a distance from the from the center of rotation, imply a riding moment. In order for the fins to be most effective, it must have a good control system. Traditional fin stabilizers used hydraulic gyro. The TRAC fin stabilizers use an electronic system with a CPU that is measuring and making adjustments hundreds of times a second. The roll sensor group have a couple sensors that not only measure rate of roll, but heel angle. So knowing the heel angle becomes important because it allows us to respond quicker. We don't have to wait for a great rate of roll. We can respond immediately to any change in heel angle because roll is nothing more than a change in heel angle. The faster the heel angle change, the faster the rate of roll. But at a very slow rate of roll, heel angle changes, we still respond. Now, knowing the heel angle has a couple of advantages. In one case, in a following C, you don't have a great rate of roll, but you have that tendency to want to broach. We are looking at the heel angle, we know where the horizon is, and we are constantly correcting to keep the boat level on its intended wetted surface, running straight. Another condition would be when you have a crosswind causing wind-induced heel. Now, you can have a condition where the boat is heeling due to the wind, but there's not much happening in sea state causing roll. The fins can correct for that heel and keep the boat level while still having some reserve capacity to take care of any roll that arises. Like gyro stabilizers, the fin stabilizers can also be used at rest or at anchor. We often refer to stabilization at rest as STAR. The at rest feature for the fins require a different control algorithm. We no longer have the advantage of the water flow over the fins to generate lift. So now we recognize that if we move the fin fast through the water, we can take advantage of the resistance of the water against the broadside of the fin. To maximize this, we generally have the fin sitting at an extreme angle, and then once it detects the roll, it sweeps through its full range of motion. Now it's sitting at the opposite direction, waiting for the opposite roll direction. So if they're working hard, they will sweep through their range of motion, sweep through their range of motion, sweep through their range of motion, all in sync with the vessel's roll period. Also, for maximum performance at rest, is we looked at the fin design. We decided if we can increase the length of the fin, we can improve or maximize the forces generated. So the STAR fins are generally about a third longer than a standard fin. Now that we've considered both systems can be used for underway and at rest, let's look at how each system's powered. The gyro stabilizers are powered by an AC motor that spools up that flywheel and then maintains that speed under operation. This requires a generator to be running for both underway and at rest. The TRAC fin stabilizers are powered through a central hydraulic system. In that central hydraulic system, there is a pump mounted either on a main engine or transmission powered takeoff. When you're underway, the pump is running because the main engine's running and no generator is required. That's an advantage over the gyro stabilizers. Now, for at rest, you typically don't have your main engine running. So then we're looking at putting either a pump on a clutched PTO on a generator or an AC powered pump. Either way, you're looking at having to run a generator for at rest. So both systems require a generator for at rest. The TRAC stabilizers don't require a generator while underway, while the gyros do. There are a couple other considerations. Startup time. The gyros require you to spool up the flywheel, which takes about 45 minutes to an hour. The TRAC stabilizers can be turned on and used immediately. Gyros naturally resist all roll, good roll and bad roll. Good roll is when the vessel's knocked over and is trying to right itself. The gyro doesn't know the difference and it's going to resist that as well. That can make for a very awkward ride. The fin stabilizers know where the horizon is, know where level is. It's going to assist the vessel righting itself and make for a much more comfortable ride. On boats, space is always an issue. And gyros are about the size of a washing machine, and having to be mounted to the hull can make finding a home for it difficult. And when you consider sometimes 2 or more gyros are required to stabilize a vessel with a large displacement, this can be difficult. Maintenance can be another issue. A large mass spinning at high RPM, anywhere from 4,000 to 9,000 RPM, is hard on bearings. These bearings need to be replaced anywhere from 6,000 to 10,000 hours. Some manufacturers require you to uninstall the equipment, send it back to the factory to get refurbished, then reinstall. That can be a major, it's like a refit and a major cost. The TRAC stabilizers can be maintained in place. We require to change the hydraulic cylinder at about 2,000 hours and shaft seals at 5 to 6 years during a normal haul out. If you are considering gyros, you certainly should contact the manufacturer and discuss any long-term maintenance requirements. Now, I think the best reference for anyone considering putting gyros on a Nordhaven is the fact that it's been done before. I know of one vessel that installed gyros in the factory, so an ideal condition, not a refit. Now that that vessel, after a couple of years of operation, ended up getting TRAC stabilizers refit onto it. I think that speaks volumes. One last note. I've talked about stabilization at sea while underway and at rest. But whoever thinks about stabilization on land? Imagine cruising in an area with great tidal change, like Alaska. Now, these remote areas don't always have the best charts, not up to date, so it's not uncommon to touch bottom. Now, imagine touching bottom as the tide's going out, and now you're stuck on land. Our TRAC fins were used as a kickstand in this application to keep the boat up. I have a hard time believing the gyros would have been able to keep this boat safe. I appreciate your time today to join me for this presentation, and hopefully you'll be able to stay on and for the question and answer period coming up next. Thank you.